All right, so without delaying things any further, let's jump in and get started. We don't have a lot of people today, so in that regard, I suppose that's quite nice because at least it means that there's plenty of opportunity for you guys to ask questions, etc., etc. We'll see if some more people join us in due course. All right, so we have here the graph of g of x with equation ax cubed plus bx squared plus cx. So straight away, when we read that, we see that they haven't included the d value. So normally at the end, it's ax cubed plus bx squared plus cx plus d. In this case, the d is not there. Why isn't it there? Look at the diagram and tell me, why have they not included the d? Can anybody tell me that? Absolutely, because the y-intercept is 0. The graph goes through the origin. Good, Nhlanhla, perfect. Right, and then it goes on to say a cubic function having y-intercept of 0 is drawn below. The x-coordinates of the turning points are -1 and 2. So you can see that they've indicated the x-coordinates of the turning points on the diagram. They've got the -1 and the 2 in there. Okay, so now let's go and have a look at the questions. The first question says in 8.1, for which values of x will g increase? For which values of x will g increase? Now, what does the word mean? Well, what does the word increase mean in maths? It has a specific meaning in maths. What does the word increase mean? Especially when we talk about a function. There we go. Good, Nhlanhla, perfect. So Nhlanhla has written there for us, it means a positive gradient, which it certainly does. So the word increase or increasing means there is a positive gradient. And a sort of layman's way of thinking about a positive gradient, it means you're walking uphill. As you move from left to right, you're going up instead of down. Okay. The word decreasing is the opposite. It means a negative gradient. So in other words, if you were walking from left to right across the Cartesian plane, you would be walking downhill. So for which values of x will it increase? Okay, so this cubic function from positive infinity to this point over here, what is this graph doing? The bit that I'm highlighting in blue, is that increasing or is it decreasing? This bit that I'm highlighting in blue, is that increasing or decreasing? It's decreasing, quite right, Kalipa. And it's decreasing, quite right. And it's also decreasing after this turning point as well, because I'd also be walking downhill if I was walking along that blue bit over there. So that's where it is decreasing. Right? Increasing is the opposite. The gradient needs to be positive. So let's use a different color. So walking from left to right, when I leave that turning point and I go up towards the next turning point, there I'm walking uphill. I am increasing. So between which x values is the graph increasing? Okay, so Kalipa, you've just got your inequality signs the wrong way around, but that's not the end of the world. Good, Yamkela. Good, Zechofatso. Perfect. All right, so when x is a number that's bigger than -1, but smaller than 2. All right, so where x is greater than -1, but smaller than where x is equal to 2. Now, I want to ask you another question. Nhlanhla, there we go. So Nhlanhla says where x is greater than or equal to -1, but smaller than or equal to -2. Sorry, +2, sorry. That wouldn't make any sense otherwise. Whereas Sechofatso and Yamkela have left out the equal to. Who's correct? Is it better to put in the equal to? Is this a case where we would have equal to, or would we not have equal to? You think not? Why not? Why not? Why is it why should this answer not be greater than or equal to, but smaller than or equal to? Why not? Why are we leaving out the equals here? There we go. Good, Cheslin. Well done. So Amashle, Lebogang, you both said you think not. Perfect. Cheslin said that is because when x is -1 and when x is 2, these are turning points. Okay. Absolutely. And Lebogang said the same thing. Okay. It's stationary. Okay. It's a stationary point. Absolutely. So the word turning point is a better word to use than stationary, but there's nothing wrong with calling it a stationary point at all. Okay. So the word stationary in this regard, in the case of maths here, stationary means that the gradient is neither increasing nor decreasing. So if it is a stationary point, stationary means the gradient is neither positive nor negative. So it is neither positive nor negative. And we all know by now that the gradient at the turning points is 0. Okay, we're not going up and we're not going down when we are at the stationary point. Good, absolutely. All right, so we would exclude -1 and 2. In order to have this 100% correct. Okay, lovely. And you would get 2 accuracy marks. There's no other way that you can write this unless you want to use interval notation. So the only other thing you can do is say x is an element from, and then you'd use a round bracket because -1 is not included. And then you'd say 2, and you'd also use a round bracket. Okay, so here it would be 2 accuracy marks, perfectly correct, or 2 accuracy marks there, perfectly correct as well. Okay, now they want us. No, you don't, Amashle. So it's up to you. I prefer the first one, the set builder notation, to the interval notation, but it's totally up to you. Some people prefer writing the brackets. I just feel that to remember the numbers as well as the brackets is a little bit much. I think the first one is easier, but it's totally up to you. But no, you don't have to write it in both ways. It's just 2 different ways of writing the same thing. So those are your options for answers. Now they want us in 8.2 to write down the x coordinate of the point of inflection of G. How are we going to calculate the x coordinate at the point of inflection? And we don't have the equation. There's only one way we can do it now. What are we going to do? Let's have a look what you guys are saying in the chat. There we go. Good. And Nhlanhla's written down the right answer. So has Tehufatso. Does everybody else knows where this comes from? They're both saying that x is equal to a half, but do you guys know where that answer comes from? What method did they use to get their answer? No. Okay. So Kalipa, no, they weren't differentiating. We don't have the equation of g of x. So even if we did find the second derivative, it wouldn't help us because we'd have too many unknowns in order to be able to solve it. So we can also calculate the point of inflection using, there we go, the midpoint of the x-intercepts. Thank you, Nhlanhla. Perfect. So we can use midpoint formula. Just like when we want to find the coordinates at the turning point of a parabola, if we have the x-intercept, we can use midpoint formula. It's the same idea. So your point of inflection will always be midway between your turning points. So we can use midpoint formula. And it's very important that you know that, because if you didn't, you would struggle to answer this question. So midpoint formula, we're going to add together the -1 and the 2, and then we're going to divide our answer by 2, and that's where they get 1/2 from. Okay, probably better to write it like this, but that's better than writing next to. There we go. Good, Tegofat. So perfect. Well done. Thank you for explaining that so nicely. Okay. So here it says say write down. So I'm not sure whether they give you a mark for subbing in and a mark for your answer. Probably 2 accuracy marks on the answer like that. So don't forget about that one. Okay. Alrighty. Now, the next question, for which values of x will g be concave down? For which values of x will g be concave down? So what do the words concave down mean? Can anybody explain that to us? What do the words concave down mean? So concave down refers to, yes, absolutely, Kalipa. So if we had a parabola and your parabola was shaped like that, we would say that it is concave down. So we know this as sad face. That's what we learned back in grade 10. If a parabola was like this, we would refer to that as concave up or happy face. All right, so the point at which your graph changes from being concave down to being concave up is called the point. Oh, you're even writing down answers already where the graph is decreased. So no, it's not where it's decreasing, it's where it's concave down. So it will be concave down before or after this particular point. That's it, Zegofat. So perfect. All right. And Cheslin saying from the point of inflection to infinity. That's it. Well done, Cheslin. Quite right. Okay, but we're not going to include, yeah, you didn't include it. Lovely. Well done. Okay, so the graph changes from being concave down, concave up to being concave down at the point of inflection. All right. So from this point onwards over here, if that blue dot represents my approximate point of inflection, the part highlighted in yellow is where it's going to be concave down. All right, so your graph is increasing and decreasing. Well, first decreasing, then increasing, then decreasing. The gradient is 0 at the turning points. That's your first derivative when you're talking about gradient. Your second derivative when you're talking about concavity, first the graph is concave up. Then at the point of inflection, the measure of concavity is 0. Just like when you're at the turning point, the measure of gradient is 0. Right, so first this graph is concave down, sorry, concave up. Your pardon, first it's concave up, and then after your turning point, it's going to be concave down. So quite right, in Ntlanhla, what you had said there, where x is greater than 1 over 2, that is the values of x for which g is going to be concave down. So again, if you want to, you can write that using interval notation. All right, so you could say all x is an element from round bracket, a half to positive infinity, and close your bracket like that as well. Okay, so yet another 2 marks over here. So this question over here, this question over here, this question over here, these are all level 1 questions. All right, they are knowledge questions. They are trying to get you to explain things about the graph that you should know. Comes from your learning, your studying. These are discussions that your teachers would have had with you in class many times about the graph. Okay, so everybody should be able to do the first 2 questions, sorry, first 3 questions without any difficulty. Now things start to get a little bit more complicated. In question 8.4, they tell us if g prime x equals minus 6x squared plus 6x plus 12, determine the equation of g. So what have they given us here? This thing that I'm highlighting in pink, what does this represent? What does this pink thing represent? And how is it related to the cubic function? Yes, it represents the gradient. Cool. But what else does it represent? It's not just the gradient. There we go. It's the first derivative. Okay, fine. Aha. And where does the parabola fit into the picture here? Lebogang, where does the parabola fit into the first picture? Where does the first derivative fit into the picture here? Can anybody explain that to me? Okay, all right. So let me explain this to you then, since you guys are obviously struggling with this. So g prime x equals minus 6x squared plus 6x plus 12. Yes, you're right. It is the gradient and it is the first derivative. What they are trying to do here is they're trying to give you the equation. Okay, so this is the equation of the graph of the first derivative which happens to be a parabola. So in course of the x-intercepts of the parabola, the turning point of the cubic, you're on the right track. That is true. There we go. And Nhlanhla quite right. Okay, so you need to use the graph of the first derivative in order to solve the equation of the original function, doing exactly what Nhlanhla has said. Okay, so we can see here we've been given g of x equals ax cubed plus bx squared plus cx. We are going to derive that. So if they give us, I'm going to write it down for us over here, g of x is ax cubed plus bx squared plus cx. This is the equation of this cubic. If we take the first derivative, we would end up with 3ax squared plus 2bx plus c. So now what we need to do is we need to say, well, this term over here is that term over there. So minus 6x squared is your 3ax squared. So there is your way of solving for a. Now that we have got our variables, our x squareds are the same, we can equate the coefficients. So this means we can take 3a and make it equal to negative 6, in which case a is equal to negative 2. Then we are going to have a look at the second term. That is 6x. So again, that is the same as this term over here. They've both got an x in them. So you would take 2b and you would make it equal to 6. Divide both sides by 2, and b would be equal to 3. That's it. And then the last term, Let's choose a different color for this one. Let's go with green. C would be equal to 12. Quite right. So therefore, the equation of g of x, now we can go and sub back in. A was equal to -2, so that would be -2x cubed. Then the value of b is 3, so this would be plus 3x squared. And c was equal to 12, so here we would say plus 12x, like so. Quite right. Okay, now, Yamkela, I see you said in the chat you don't understand. What is it that you don't understand? Can you explain to us? Yolanda, maybe you can reach out to Yamkela and just see if you can help them with this. Is that all right?
Yes, I see their hand is
Okay.
up, but I can
Oh, okay.
help.
All right. Okay. All right. Well, I'll tell you what, you reach out to Yamkela, and if they still don't understand it, we can talk about it a little bit more.
Okay, cool. I'll
Okay.
do that.
All right. Cool. Thank you so much. Yamkela, Yolanda is coming to assist you. All right. So if we need to talk about it a little bit more, we can. All right. So where would we get our marks here? Well,
Ma'am.
Yes, Yamkela.
Yamkela, you can talk to me on the chat. I've said hello to you. So we can just chat, and like this teacher Lee can continue. And then we can chat quickly so you can catch up also. I think it could be network.
Okay. All right. So guys, there would definitely be an accuracy mark on taking the first derivative. And then I think there would be an accuracy mark on making 3a equal to -6. And then I think they would give you continuous accuracy. No, there wouldn't be continuous accuracy marks because we're not using our previous answer. Sorry. So I think it would be a mark there and then a mark there, and that's why it's out of 4 marks. Yes, exactly. Exactly, Abraham. We're working in reverse to get the equation of the cubic. Okay, so the graph of the derivative is given to us. We derive our cubic function, and it's the same thing. Okay, so g prime x is g prime x. So we're just going to use, what's the process called? Let me just think of the word. We did it when we were solving cubic equations as well. I cannot think of the word now. Hang on, let me see if I've got a maths textbook here. Inspection, that's it. So we're using inspection, okay, to help us solve the values of a and b and c. All right, so we observe that 3ax squared is the same as -6x squared. So we're using inspection in order to be able to solve for a, b, and c. All right. Okay, let's go and have a look at the last question. This is going to be a little bit more of a challenge. This is question 8.5. And here it asks us to determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y equals mx plus c. So now we have to go back and think very carefully, all right, about what do they mean when they talk about the maximum gradient? What do the words maximum gradient mean? Where is gradient at a maximum on your cubic function? So no, Lesego, your gradient is going to be at a minimum at the turning points. Nope. Nope. So listen carefully again, guys. I'm going to ask the question again. So The gradient is at a minimum at the turning points. That's where the gradient, I suppose it's not a minimum, but it's where it would be equal to 0. Aha. Now, I want you to, before I go any further, Nhlanhla, I want you to explain to me how you know that. That's it, Lebogang. How do you know that? How do you both know that? Indeed. You're going to have to derive, quite right. But I first want to establish how both Lebogang and Nhlanhla knew that the maximum gradient is going to be at the point of inflection. Can you tell us that, Nhlanhla? Do you know why? Okay, so Nhlanhla's quiet now, unless, of course, they're typing. Lebogang's also quiet now, unless, of course, they're typing. Oh, they were typing. Okay, let's see what the second derivative of g gives us the gradient. No, the first derivative of g gives us the gradient. The second derivative of g gives us the point of inflection. But you're quite right. Your graphs is going to, well, any tangent to your function is going to be at a maximum gradient at your point of inflection. That's quite true. Yes, because the slope is up, absolutely. So what happens is that it comes down, it gets to 0, and then it starts to climb slowly at first, and then it gets steeper and steeper and steeper and steeper and steeper until it gets to the steepest it can be. And then as it approaches its next turning point, you can see where my mouse is, it gets less steep and less steep and less steep and less steep. Okay, until it gets to the turning point where your gradient is 0, and then it's going to drop off again. All right, so that is quite right. The point of inflection is the point at which you will have the maximum gradient of any tangent to the function or on the function itself. Okay. All right, so now, in order to work out the equation of a tangent to a function, what are the 3 magic ingredients that we need to get the equation of a tangent? So sorry, this was question 8.4. What do we need when we want to get the equation of a tangent? There are 3 things that we need. That's it. So we need the x coordinate at the point of tangency. We need the y coordinate at the point of tangency, and we need the gradient at the point of tangency, 100%. Okay, so do we know what the x coordinate at the point of tangency is? Have we already got that piece of information? Yes, it's 1/2, and we got that piece of information from question 8.2. So we know that this is 1/2. So if we have got the x coordinate, yes, it is a half. Well done. How are we going to get the y coordinate at the point of tangency? Where is that going to come from? You're looking at it on the screen at the moment. That's why I moved it down a little bit. How are we going to get the y coordinate? That's it, Nhlanhla. We're going to sub x into g. Well done. So we're going to calculate g of a half. So we're going to sub that in. So we've got -2 times a half cubed plus 3 times a half squared plus 12 times a half. And what do we get? That's it, into causal, and substitute into g. What do we get here, guys? Okay, so Tsegofatso's put an answer there. The rest of you getting the same answer, Tsegofatso? I'm also just working it out quickly. We get 13 over 2. Beautiful. All right, so we're all getting 13 over 2. Okay, so that is 13 over 2. All right, nice. Okay, next point. All right, now we need the gradient at the point of tangent C. So how are we going to work out what this maximum gradient is? What are we going to do? Can anybody tell me, how are we going to get the gradient? So the information is there on the screen in front of you. You just have to know what to use where in the correct way. How are we going to work out the gradient at that point? What does the first derivative represent? The first, exactly, absolutely, Lebogang. Okay, by the first derivative. Okay, remember they gave us the first derivative. Now, again, I know this is a little bit more difficult for you guys because I've got the questions right in front of me. That's it, Zehofatso, quite right. Okay, but it's a little bit harder for you because you're dependent on me going up and down and you seeing the information. Whereas, if this was on a piece of paper in front of you, it would be a little bit easier. Okay, but we've got the equation of the first derivative. Remember, they gave that to us in question 8.4. Right, so now we're going to do exactly what Zehofatso says. We're going to sub 1/2 into the first derivative. So g prime x, we're going to sub in our half, and that gives us -6. And then we're going to put in our half, and we're going to square it, plus 6 times 1/2, plus 12. And what do we get as an answer here? We get 27 over 2. Well done. 27 over 2. All right, good. So our gradient, our maximum gradient is 27 over 2. Now, that's why we call these the 3 magic ingredients, all right, for determining the equation of a tangent, because now we can use that information to help us figure out what y equals mx plus c is going to be. So we've got y equals mx plus c. That gives us a structure to sub into. So the y at the point of tangent C is 13 over 2. The gradient is 27 over 2. And the x coordinate is 1 over 2. This is going to allow us to calculate the value of C, which is going to be the y-intercept of this tangent. There we go, Tsegofatso, quite right. So now what we would need to do is multiply 27 over 2 by 1 over 2 and take that away from 13 over 2. All right, so on the right-hand side here, we'd have 13 over 2 minus 27 over 4. So we can put that into our calculators and we get, what are you guys getting? A -1/4, quite right. Okay, so Tsegofatso and Nhlanhla, you've put up the correct answer. So minus 1 over 4. So therefore, the equation of this tangent, so 27 over 2 is the same as 13 comma 5, if you want to write it like that, minus 0 comma 25, because that's a quarter, or if you felt like keeping it with the improper fractions, that's not a problem either. It would be 27 over 2x minus 1 over 4. We generally wouldn't mix decimals with common fractions or improper fractions, but I don't think you would get it wrong if you did. Okay, there we go. So there is the equation of our tangent. Everybody happy? Are there any questions? Beautiful. Good. So Letabo, I've put the marks over there for you. There'd be a mark on you calculating the x-coordinate at the point of tangency. Sorry, there wouldn't be, I beg your pardon. Would there be a mark for you knowing that since you've already calculated? No, I think there would. I think there would be a mark because you need to know that. So there would be a mark for knowing that the maximum gradient is where x is equal to a half, your point of inflection. Then working out what the y coordinate is at the point of tangent C, and then a mark for calculating the gradient of the tangent, then a mark for subbing into y equals mx plus c, and then they would probably give you a mark on calculating c correctly. Okay, because you've got your gradient and you've got your y-intercept. Okay. All right, fair enough, Amahle, but at least now what I would suggest you do is make little notes of the things that you are struggling with. Okay, so that when you go and you study, you can focus on the things that you are now discovering that you don't know. Okay, because at the end of the day, I know this sounds silly to say it, but we don't know what we don't know, do we? If we don't know what's in the syllabus and there's bits and pieces that we've missed, we don't know what we don't know. All right, so once these things become obvious to us that we don't know how to do them, make little notes, and then you can go and study these sections. You have to keep practicing, guys. It's important that you revise regularly because that's the only way that these skills and this knowledge becomes permanent for you until you obviously write your exams. Okay, so even for me, I've been teaching maths for 16 years. And before I go into my classes, okay, not a grade 8 class or a grade 11 class, but certainly if I'm teaching a 12A class or a top class, I always make sure that I revise and look over things and look for new questions and look over stuff before I start talking. Okay, so if teachers need to do that, then as students, we also just got to keep revising because none of us remember something that somebody told us once. Okay. Absolutely, absolutely, Chesing, because your CAP syllabus is so vast. It's so deep. There are so many things that they could possibly ask you where you really do have to apply your knowledge. Absolutely. All right. So, yeah, if you don't have that knowledge in the first place, then you can't apply anything to anything. All right. Okay, guys, you've got this. I know that you can do it. Yolanda and I are here to help you as well. Okay, what I want to do now, if it's all right with you guys, is I just want to go back to our lesson from Tuesday quickly, and especially with problem solving. Absolutely, Lebogang. So 15% of any paper is going to contain problem solving sorts of questions. This question 8.5, I don't think would be regarded as a problem solving question. It's definitely complex, but I don't think it's problem solving. A problem solving question is something where there's no clear starting point. So if I can go back to a question like, is it okay if I go back to this? I just wanted to finish this off with you. 10.4, we never did this on Tuesday. Can I finish 10.4 with you guys? Is that okay? Do you remember this question? Cool. All right. So this is an example of a problem-solving question. When we had to prove that AD was a tangent to the circle, that would be considered complex. All right. Where the question says 10.1, give a reason why AF equals FE, that's knowledge. So we know by now that our paper is going to be 20% knowledge, 35% routine procedures, 30% complex, and 15% problem solving. Okay, so these are the different categories in maths where things get asked. All right, so question 10.1 is knowledge. Question 10.2 actually would probably be how much working did we have to do, a little bit over there. So that would probably be seen as routine. Question 10.3 over here would be seen as complex, maybe easy complex, and question 10.4 would be problem solving. Probably not difficult problem solving, but it would be problem solving. Okay, there's no clear place. Remember, we looked at the diagram and we knew a few bits and pieces, but there was no clear place where we needed to start. All right, so in 10.1, you can see it's very directed. Give a reason why AF equals FE. All right, whereas here, we've just been told two bits of what appear to be random information, and based off of that, they want us to calculate the length of AE. Okay, so this is a problem-solving question. Now, somebody on Tuesday afternoon brought up the midpoint theorem. Now, they were on the right track, but if you want all the marks in geometry, you have to explain where your argument is coming from in a logical manner from start to finish. So I can't use midpoint theorem unless I have parallel lines. So what I needed to establish first of all in question 10.4 is why CFMD, this diameter, is parallel to AB. All right, so what you are doing here is you are looking at, let's get a different color. I'm going to use pink. You are looking at this triangle. Okay, we want to show that FM is parallel to AB before we can use midpoint theorem. Midpoint theorem tells us that if we have two midpoints, okay, which we do, we've got FE is equal to FA. We would have to explain that as well. Okay, because Amatle, you want to use midpoint theorem to work out the length of FM. You want to work out the length of FM because you want the length of the radius. You want the length of the radius because you want the length of the diameter BE, and you want the length of the diameter BE so that you can use 24 and the theorem of Pythagoras to work out the length of AE. Does that make sense to you? So I've kind of explained the entire problem, how you need to do it. Do you want me to say that again? Maybe I said that a bit fast.
Ma'am,
Mm.
can we say that CM is 12? Because
Not CM is 12. CM is 18. CM is 18. So FM will be 12.
okay.
FM will be 12.
Okay.
Okay. So first of all, so this is what we need to do, guys. All right. We want to calculate the length of AE. We're going to calculate the length of AE using the theorem of Pythagoras in the pink triangle. We've got the length of AB. We don't know the length of AE. That's what we want to calculate. So in order to calculate the length of AE, we need the length of the hypotenuse. The hypotenuse is the diameter. So if I calculate the length of a radius and double it, I've got the length of the diameter. So your radius MC, you know part of that. You know CF, but you don't know FM. So we are going to do midpoint theorem in triangle EAB, so that we can calculate the part that's missing from CM, that is FM. Okay, and now in order to do midpoint theorem, in fact, I'm just thinking if we could avoid doing, no, we would have to state that the lines are parallel. So there's two ways in which we can do this. All right. First of all, what we could do is we could say EF equals FA and EM equals MB. All right. Therefore, FM is parallel to AB and FM is half of AB, midpoint theorem. We could do that. Or we could use line through midpoint parallel to second side. Okay, exactly, because of it's not a corresponding angle. It's so CFA was the same as FAB. So we could use alternate angles to prove that the lines were parallel. And then we could also work out the length of FM using line from center not line from center, line through midpoint parallel to second side. But I think what I'm going to do is you're probably more familiar with midpoint theorem. Is that true? Do you know what I mean when I talk about line through midpoint parallel to second side? Does that ring a bell? You know what I'm talking about? Okay, so Lebogang says yes, but not anyone else. Okay, so then what I'm going to do in that case, Lebogang, since, okay, and Tlantla said yes, okay, well then I'm going to use line through midpoint parallel to second side, but I can also use midpoint theorem. Okay, what I'm going to do, guys, I don't think I need the answers from 10.2 and 10.3 here. So I don't want to not finish this question this time. So I'm just going to rub that out and then I'm going to write in the space over here. And see, again, to answer these problem solving questions, our knowledge needs to be so good. So if we've never heard of line through midpoint parallel to second side, how can we possibly use it if we don't even know that it exists? All right, so let's go that route here. All right, so 10.4. This is what I'm going to do. I am going to say that angle CFA equals 90, and that was given to us. I am going to say that angle, remember we discussed that angle A2 plus angle A3 was also equal to 90. Okay, so I'm going to say angle, I'm going to call it EAB rather. I'm going to call that 90, and that was angle in a semicircle. Okay, so that means that CFA equals EAB because they both equal 90. And that means that I'm going to call it CM is parallel to AB because alternate angles are equal. Now I'm working in triangle EAB. I've got a midpoint and a pair of parallel lines. So EM equals MB radii and FM, so I could call this CFM if I wanted to, and FM parallel to AB proved above. So therefore, FM is equal to half of AB, line through midpoint, parallel to second side. Line through midpoint, parallel to second side. Now I'm going to substitute. Therefore, FM equals half of 24, which is 12. Okay. So I was given that CF was 6. So CFM is equal to 18. So therefore, CFM or CM equals 18 units. CFM is a radius. Do you all see that? CFM is a radius. Oh, I'm going too fast. Sorry, Tsegofatso. Okay. Sorry, I'm just going fast, Tsegofatso, because I'm worried about running out of time and I've got load shedding coming up and the next class is going to start at 6. My apologies. Okay, so this angle over here is 90. That was given. This angle over here is 90 because of angle in a semicircle. So CFM is parallel to AB because alternate angles are equal. Okay. Now in triangle EAB, I'm doing line through midpoint parallel to second side. Okay, so I've got EM equals MB, their radii. FM is parallel to AB, proved above. So FM is half of AB, line through midpoint parallel to second side, so FM is 12. So CFM is 18. That is a radius. So CFM equals BM. So CM equals BM equals ME. Okay, because they are radii. So that means that BE, which will be the diameter, BE will be the diameter, that will be 36 units. Okay, and now I can do the theorem of Pythagoras. Okay, so AE squared plus AB squared will be equal to BE squared because of Pythagoras. So AE squared plus AB, they told us, was 24. We've calculated that BE is 36. Oh gosh, what am I doing here? Sorry. What am I writing? I meant 36 squared. Sorry, it's been a long week. Okay, so AE squared will be 36 squared minus 24 squared, which gives us 720. And then we're going to take the square root of that. Okay, so therefore AE is equal to 12 root 5. Yes. Or 26,83. Okay. All right, that is a problem-solving question. Let's see, Nhlanhla, so you said EFD equals CFA, vertically opposite, therefore corresponding angles. Yeah. You could do that too. Yeah, absolutely. And of course, this bit where they've said line through midpoint parallel to second side, we can also use midpoint theorem here too if we wanted. Okay, so can you see it's a logical argument from start to finish? All right. I need to prove that those lines are parallel in order to be able to work out the length of FM. Once I've got the length of FM, I've got the length of the radius. Once I've got the length of the radius, I've got the length of the diameter, and then I can do Pythagoras in that right angled triangle. Okay.